You know, when you think about keeping robots safe, your mind probably jumps to things like cameras or even those big physical cages. But what if the best safety feature wasn't a thing at all, but a decision? One made before a robot even moves. Well, today we're going to look at something totally different. This is ARTANI Gate, and it's basically a firewall for physical AI.
So that gets us to the real heart of the issue. See, most safety systems we use today are reactive. They kick in after something's already gone wrong. But what if you could catch the problem right at the source? So how do you stop an accident before it happens? Not while it's happening, but in those tiny milliseconds just before it even starts. Well, the secret lies in this really critical window of time. You could call it the robot's risky moment. It's this tiny, almost invisible gap between a computer saying, "Hey, move your arm," and the robot actually starting to move. And that's the blind spot. That's exactly where ARTANI Gate gets to work. Honestly, the best way to wrap your head around this is to think of a firewall, like on your computer. But instead of for data, it's for a robot's actions. So before any command can become a real physical movement, it has to get past this gate first. The system looks at what the command wants to do and makes a judgment call, all before a single gear turns.
So the official term for this is a pre-execution safety OS. Basically, for every command it sees, it gives one of three verdicts. Should the action be allowed? Should it be monitored with caution, or should it be blocked completely? Yeah, you can really just think of it as a traffic light for everything that robot is told to do. Simple as that.
Okay, that all sounds great in theory, right? But let's see how it actually works in practice. We're going to walk through three different scenarios here. A totally safe one that's a little sketchy, and a really dangerous one, just to see how this thing makes its decision in literal milliseconds.
All right, first up, we've got a super normal task for a factory robot, a classic pick and place. The system takes a look at the command and, yep, no surprise here, it gives it a big green light. Verdict, pass. Nothing to see here. Now, let's look at the number behind that pass. The system gives this action a risk score of just 0.484. And since the threshold for a pass is anything below 0.8, this is way, way in the safe zone. It's not a guess, it's a data-driven green light. So, here's the why behind it. The system sees that all 6 of its motion axes are totally normal. The movement isn't jerky or volatile. Basically, the behavior is considered safe. So the next step is simple. Execution is allowed. The robot gets to work.
Okay, next up, a different scenario. We've got slightly unstable repeated motion. Now, the robot isn't about to crash into something, but something's just a little bit off. And you can see the system's verdict immediately changes to a yellow warning.
And the risk score tells you why. It's 0.841. Now remember, 0.8 was the cutoff for a clear pass. We've just tipped over into that yellow monitoring zone, which runs up to 1.05. The system is basically saying, hey, you need to pay attention to this.
And here is where this thing gets really smart. It doesn't just slam on the brakes, it actually gives a solution. It says the behavior is uncertain, right? So it recommends cutting the robot's speed by 30% and having a human keep an eye on it. That's a safe, productive compromise. All right, now for the big one, the critical test. The system is given a command that it flags as a high-risk collision scenario, and there is zero ambiguity here. The verdict is instant, it's decisive, a hard fail. And just look at the risk score. A whopping 1.674. I mean, that's miles above the blocking threshold of 1.05. This isn't a suggestion, it's not a warning. It's a hard red line that the system will absolutely not let the robot cross. And the system's final word? It's absolute. Execution blocked. Robot must be inspected and reprofiled before restart. The gate slams shut. The accident is stopped before it even had a chance to happen.
Okay, so we've seen how it handles a single command, which is cool. But the real power, comes from scaling this up. How does this help an entire factory, an entire enterprise? Well, it creates safety you can actually audit.
This right here is the black box audit trail. Think of it like a flight recorder, but for your whole fleet of robots. Every single decision, every pass, every warning, every single fail, it's all logged with all the context you need. That's a goldmine, not just for safety, but for compliance, for figuring out how to run things better. And then you've got this, fleet batch simulation. Let's say you want to update some programming for a robot.
Instead of just rolling it out and hoping for the best, you can simulate that change across your entire fleet in an instant. You can see right away which robots would pass, which ones would get a warning, and which ones would fail, all without any physical risk.
And that's really the 1-2 punch right there. With the black box, you have a perfect record of everything that's happened. And with the fleet simulation, you can test every possible future change before it happens. You've got the past and the future of your operation's safety totally covered.
Now, for all you developers and engineers out there, don't worry. This isn't some clunky piece of hardware you have to bolt on. It's a service. It's a simple, really powerful API that just plugs right into the software and the workflows that you're already using.
All of this brings us to a final, much bigger idea. Yeah, this has been about stopping accidents, but the real story here is about what this enables. What becomes possible when you can genuinely trust the machine working right next to you? What happens to creativity, to productivity, when robot safety stops being a question mark and starts being a guarantee?